So, hello everybody. I hope you can see the screen. Okay, so I'm going to cover the topic of a cognitive digital twin for rail infrastructure management and operations. So, my name is Girish Soni from HCL Technology. I lead the digital twin practice. Along with me, my colleague L. Srinath is there. So we are going to show you one of the case study in the rail industry and how we leveraged AnyLogic while implementing the digital twin for the rail infrastructure. So just a quick overview on our organization. So HCL Technology is a global technology company powered by the strong pool of around 219K ideapreneurs. We have a presence in 60 plus countries, and we serve in the various key areas like into the digital engineering, cloud, AI, as well as the software aspect of it. So we are a part of EIS, which typically stands for Engineering and R&D Services. And where our key focus is that we develop the solutions in the connected design, connected factory, and as well as the connected products environment. And we enable our customers in various technologies like IoT, AI, ML based, then the cloud, digital twin, robotics, those kind of things. So outline for today's case study is that I will be covering the rail industry trends, drivers, then what is the digital twin concept which we are implementing, then what are the typical use case in the rail industry, and how we are implementing the AnyLogic in our digital twin framework. So when we talk about the rail industry, so we know that the various industries, one of the key objective they are having is a digital transformation. So it is there into, I think, 3 years roadmap or 5 years roadmap. But while doing this, there are certain trends which one would like to consider. So for a rail industry, the typical business trends are that we know that there is an increasing complexity in the rail systems as well as it's supporting rail infrastructures like the rolling stock, passenger cars, or it could be the freight or the railway tracks, signaling systems, or the switches, those kind of things. So as and when we are dealing with those kind of complexity, that behavioral data is very much important. So we are leveraging that data and how can we make those kind of asset infrastructure more smart, connected, as well as the autonomous. That is one of the key need or the ask coming from the rail industry. So from autonomous train, we should able to take the decisions the train should able to take. It should able to connect with the other entities, be it with the other train, passengers, or other entities. And how can we optimize the energy consumption? So there are sustainability aspects are also coming that how can we optimize the carbon footprint and energy consumptions. On the technological side, you can see that there is increase in the electronics usage, software aspect. Then there is a more reliance on the digital signaling, and there is a increased adoption of the IoT as well as the cloud-based solution. And when we are getting the more and data, then there needs to be equipped with the more computing power so that we should able to enable with the real-time simulation and analytics. So in a short, there is a more focus on the continuous monitoring analysis where one can predict the performance, identify the root cause analysis for any of the rail asset failure or even the infrastructure operations to it. So the key challenges in the are that how can we monitor and control the condition of the rail asset and the infrastructure, as well as the data from that data and take the decisions out of it. Then the operational challenges that there are multiple operational as well as the safety risk. How can we minimize those risks? And one of the key thing is that how can we bridge the gap between the as is process and the to be process. So in order to do the asset commissioning as well as the operations. And one of the key aspect which every uh, the rail OEMs or the operator they is looking into it is the predictive maintenance, that how to limit the downtime, identify anomalies, how can I do the maintenance planning, and even from the operator perspective, I would like to optimize the network efficiency, track capacity, and the fleet utilization, those kind of aspects. And eventually that it leads to that the compliance, then the environmental as well as sustainability aspect. And once the thing the my solution it is the well established, how can I scale it to the multiple fleets as well as various configuration and the variants. So while dealing with these challenges, some of the challenges we feel that can be addressed through the digital twin. So as you can see that we know very well that the digital twin, it connects the physical world and the digital world together, so that both of these world they interact with each other, they retrain each other, exchange the data between them. So broadly we see that the twin falls into these four categories, like the product twin. So where the OEMs they would like to see how my customers are using the product. Especially it is critical for the future design and the manufacturing aspect of it. And how can I cater the various services to my customers? So that typical use cases can be tracked through the product twin. Asset twin is where I would like to improve the performance, equipment efficiency, asset performance. So over here in the rail domain, it could be there will be the plenty of assets which is being used. So I would like to track them, their performance and carry out the predictive maintenance. Process twin is where I would like to analyze the passenger flow analysis, the intermodal transportation flow, those kind of workflows I can represent in the process twin. And the infrastructure twin is the actually encompasses all these things where the entire structures or the assets or the supporting structures which is being used in the maintaining the rail operation, that behavior which we can track through the infrastructure twin. So this is what the spectrum of the digital twin use cases we are covering, like the rail asset management, where I would like to do the rail asset monitoring control. Then in the infrastructure, I should able to do the rail yard design simulation, then the health monitoring of the various infrastructure, then the network operation, where the digital twin helps to do the dwell time reduction, then the traffic and disruption management. And one of the key thing is that how can I do the intermodal simulation, the shipment management, material flow analysis. And the key thing is the passenger experience, where I should able to enhance the travel experience, do the ticket management, real time occupancy checks through the mobile app, those kind of things. So we cater these all those kind of use cases in the rail industry. And in order to cater these needs, we have a digital twin framework. So this framework, it is applicable for the any industry. And one of the application is the rail industry, which I'm going to showcase you over here. So you can see that I'm having the physical product or the asset, and the operational data, it is getting sensed through the IoT sensors or the various devices, and that typically ingested into the IoT framework. So it could be the any of the framework, be it with Azure, AWS, or anything. So for any of the physical asset, we will have the digital twin instance, and typically it needs to be equipped with the other data, where that data it used to be reside in the model repository, like the PLM data, asset management data, or it could be the geospatial data. And for a user, it will be the UI where he should able to analyze the data. He should have the intuitive dashboard. He can analyze, take the decisions accordingly. But in order to take those decisions, they're used to have the need of the simulation. So one need to, based on this data, I should able to do the various kind of simulation, be it be the physics based simulation or the multi-physics simulation, discrete event simulation, those kind of things. So this framework, it is open for all the technology options. But when it is coming to the simulation, we feel that AnyLogic plays a very key role over here. And that is how actually we implemented uh, AnyLogic in our digital twin framework. So I'm going to show you our implementation using AnyLogic. So over here, you can see on the right side, I have the real asset infrastructure, which is in the physical world. So I'm getting the data through IoT sensors, even some of the data like the asset management data from the asset management system or the fleet data as well, which we can leverage over here. And that is getting ingested into my IoT hub. For each and every physical thing, I will have the digital twin graph where I can actually monitor each and every node for that particular asset. And that will be consumed to do the simulation and the data analytics. So finally, for a user, it will be the digital twin app where he can have the real-time dashboard, various alert notification. He can have the 3D visualization and carry out the predictive maintenance. So we have developed a real twin solution which caters all the use cases which I have shown earlier to you. And one of the key component for is the simulation layer, and that is powered by the AnyLogic. So where we can do the agent-based modeling, I can do the discrete event simulation. So we have leveraged the capabilities of the Rail library available in the AnyLogic. Even we have created the entire Rail network where I can do the process modeling as well as the passenger flow analysis. And broadly, this encompasses all the use cases which we are trying to address to various of our customers. Now, let me show you the quick demo of our solution. So as you can see that this is what the entire uh, rail network which we represented in AnyLogic, including the track as well as the passenger cars, then the rail stations, as well as the various platform and the operations on the various platforms. So over here, we even incorporated the various kind of fleets as well, whether it could be the passenger car or the freight thing. The key thing is that you can see that this is the passenger flow analysis that I would like to track down and do the capacity planning for each and every passenger. And yeah, you can see that this is the Y junction which we have implemented, which is a triangular junction. For any junction, the switch operation is the key thing. So if the train it is coming from the other track, then we should actually check the various kind of scenarios over here. So this is what the signaling systems, which we see that how it is operating. And we can do the various what if scenario analysis in the digital twin over here. The key aspect over here is the switch dashboard. So for any thing, we see that this we can get the data from the asset management system and see that how is the health of those switches, how much is the energy consumed by the switches, then how many toggle counts are being happened, and even I can track down the health, how many switches are in a good condition, and accordingly I can carry out the predictive maintenance. And this help to do carry out the group maintenance activity for any of the asset. And it is applicable for the yard operations as well as the station operations and even to monitor the entire network like the inter-terminal or the inter-yard operations. So this is how actually we implemented this rail twin. And one of the core thing at the back end and even for the visualization, it is being leveraged is from the AnyLogic. So I request Srinath to cover a couple of business benefits which we see.
Yes, Girish. So with our digital twin framework, we reduce time to market by providing pre-built reusable components and tools to accelerate the development process. Digital twin framework reduce maintenance cost by offering standardized, well-documented code and automated process, which makes it easier to identify and update issues, which like finally reduces the manual interventions, which reduce the maintenance cost. And digital twin, like in the railway digital twin, we increase the railway asset performance by providing real-time monitoring and predictive analytics. Through intelligent planning and schedule mechanism, we increase the planning efficacy. Once we have the maintenance visibility of the maintenance, we we can plan the needed inventory, which reduces the inventory reduction. We also reduce the efforts in the development, whether it is product development or anything. Please, Girish. Next slide. So the conclusion is, for this framework, AnyLogic plays an important role in the simulation layer. So in process twin, we have seen how various process infrastructure can be leveraged in the AnyLogic. And AnyLogic can be used not only for railway infrastructure and process twins, it can be used for several digital twins. So the real-time data which we get from railway assets through IoT sensors and railway assets will be used in the process model for predictive maintenance of them. So railway train framework powered by AnyLogic is scalable for different use cases. So AnyLogic provides several libraries like system dynamics, agent-based monitoring, and several libraries which are helps to make the simulation much more efficient. So this is our team, and thanks AnyLogic for providing this opportunity. We are open for the questions.
Yeah. Any
Great.
questions?
I'm sure you can see the Q&A option at the bottom of the window. There are a few questions there. If you were able to go through them, that would be great.
Srinath, can you see? Apparently, I cannot see the Q&A.
Yes, I could able to see, Girish.
Okay.
Yeah.
Did you manage to find the questions and answers?
Yes.
Okay.
Srinath,
Yes, Girish.
Can you read the questions?
Yes. Very impressive animation and UI. Is there a big noticeable computational cost to including animation?
See, this animation which we have showcased, it is powered by AnyLogic only. So we have leveraged the entities provided by AnyLogic. So the basic aim is that we would like to give the visual representation as well as the kind of a kinematics based on the real-time data. And I'm glad to share that the performance it is very good in AnyLogic, because we actually model the various kind of asset. Typically, the rail infrastructure contains the various assets. So I just shown you the few glimpses of those assets, but yeah, there are many more assets which we can actually model and animate in AnyLogic. That is quite possible. Srinath, next question.
Yes, Girish. Is the network you have just shown generated automatically, or do you build it manually for the different stations? Do you use a rule engine? Um,
Yeah, so good question. So this network, we need to model it. As I say that we need to, for a digital twin, first is the analytics part. Then the second one is that we need to take it to the physics-based level. So where I need to model that network, but that typically will be the kind of a one-time activity. Now coming to the rules engine, so yeah, we need to consider the various kind of rules, because they're used to have the interdependencies between the workflows. And even being the leader in the system integrator space, typically we used to get queries from customer where they used to have the various systems like the geospatial system and other systems. So even we are integrating those geospatial aspect or the weather data as well on top of the existing model.
yeah. Does 3D animation help in covering any blind spots compared to logical or 2D view? Or is it a presentation layer only for aesthetics?
Uh, it will cover a few of the blind spots, but honestly, it doesn't actually cover the entire spectrum. So that is how we enabled the 2D tab as well as the 1D tab, where one can see that the process view as well. And even one of the thing is that one would like to see the entire network. So we implemented a kind of network control panel. So if any of the blind spots are there, we should able to identify it, or at least we should able to plug in those historical data of the blind spots, if any, so that in future we should able to take care of it.
Yeah. Why you select in the simulation analysis any logic? What is your parameters over the other simulations, of course?
Yeah, so one of the key case is that in the engineering analysis, we know that there are tools like to do the finite element analysis and thermal analysis kind of thing. That is fine. But when it is coming to the discrete event analysis, or to analyze the what if scenarios, so what will, and typically the digital twin, the main objective of the digital twin is that to do the various kind of what if scenario analysis. And that is where we see that AnyLogic uh, has the very added edge, that with the given set of parameters, I would like to analyze the various scenarios and which scenario will best fit my need. So that analysis can be done quickly in the AnyLogic, and that is how we come to the conclusion that yes, AnyLogic can be the right choice for those kind of simulations.
And in your in your model, are you running a parallel view of the reality, or are there decisions being made on test things like what would have happened?
Yeah, correct. Yeah, so uh, yeah, that is what the aim of the digital twin, that we need to replicate the real life condition, and as if I am working in the real life scenario. But let me tell you that yes, this data, as and when we get the data, we are doing this analysis. So it will be the near real time, not exactly the real time, because that there used to have some lag from the IoT platform or the this data pipeline from the IoT hub and those things. Now, coming to the question, what was the second question? I lost it.
Yeah. Are there decisions being made and test things like what would have happened if?
Yeah. Yeah, so the key thing is about, yeah, so based on this current behavior, yeah, I can track down the real-time thing. But even the digital twin or this rail twin, it helps to do the forecasting that what can happen next, or and it will help to take any kind of remedial actions accordingly. So that is what the beauty of this rail twin.
Whether freight and passenger data collected historically or made available in the real time while simulation ran.
We use the hybrid approach because for any kind of AI ML thing, we need a historical data to train the model, to analyze the pattern, to identify that how my model is accurate or not. So for that purpose, we need the historical data. And once the model is trained, we validate that it is giving the right or the accurate results. Then we ingest the real-time data and then do the kind of analysis and the prediction.
How much development time did this model take to design and build?
Yeah, so for this thing, see, we developed this based on our HCLTech digital twin framework. So the framework it was already developed by us, and based on that, and now it depends on the kind of use cases which we would like to devise. So the span it around based on the complexity of the use cases, it is between 3 to 6 months.
Okay. Yeah. Could you please elaborate what are the agent-based features in the model?
Yeah, so we use this agent-based modeling as the Rail library over here. So let's take the example for the even the passenger flow analysis or the ticket management systems. So there will be the various kind of entities one would like to configure and see and how it is operating. There will be the multiple scenarios. So we are leveraging those the features from the agent-based modeling in available in AnyLogic and then implemented in our framework.